We're going to move on into the next section, and we're going to talk about different kinds of functions. So in grade 9, you studied the linear function, which was the straight line. And then in grade 10, you studied the quadratic function, which is our parabola, and what we did last unit. And now we're going to take a look at a whole bunch of other functions. And the main focus is we're going to think about how these functions are similar in their transformations. In other words, and how they move along a graph, how they have some similarity. So we're going to get started here, and we're going to talk about the quadratic function. So the graph of f of x equals x squared. And so if this is my x and this is my f of x, or my y value, my output, let's go in between -2 all the way up to +2. So we really only need five points in order to do our base function. You can throw in more than that if you'd like, but really 5 is all we need for this. So if I put a -2 in for my x squared, I get -2 squared, which is 4. And if I put a -1 in, I get -1 squared, which is 1, and 0 squared, which is 0, and 1 squared, which is 1, and 2 squared, which is 4. So that means that my graph, if I was to graph this, if I go to -2 and I go up to 4, I can put a point. If I go to -1, I +1 and put a point. 0, 0, 1, 1, and then 2, 4. And lo and behold, you can see this parabola that emerges from that. So we have our vertex, and then we have a couple of points on either side. Okay, so when we talk about our quadratic, we talk about the base graph. This is what we mean by the base graph. And it's because we haven't done anything else to the function. Like we haven't added any numbers to it, or multiplied, or divided, or anything like that. So that's the very, very basic function, x squared. Okay, so make sure that you can create your table of values for your quadratic. And you don't need to put in your actual calculations for your y values. We can just put in the answer. So 4, 1, 0, 1, and 4. Okay, so there's our base function for the quadratic. Let's move on. Let's talk about our next function. Let's talk about the square root of x. So again, this is our x. This is our f of x, or our y value. Now, I'm going to have to be a little bit strategic in the numbers that I'm going to pick to be in my table of values, because I want to make sure that I can find the square root of those numbers. So, for example, I cannot use any negative numbers because I cannot find the square root of a negative number. So the lowest number that I can use is actually 0, and then 1, because I can find the square root of 1. And then the next number that I can find the square root of would be 4, because I can find the square root of 4, and that would give me a nice answer. And 9, square root of 9 gives me a nice answer. And then 16. So here are my 5 points. And I've chosen these points specifically because I can find the square root of these numbers. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. Square root of 9 is 3. Square root of 4, or 16, is 4. And the square root, oh, we're done. Okay, so you can see now that by picking these x values, it allows me to find the square root with a nice number. Okay, so let's plot these points. 0, 0, 1, 1, and then 4, 2, 9 and 3, and then 16 and 4. And what we get is, oops, something like that. So this is our square root graph. Okay, and it's their base graph. So that's where we start before we start manipulating it, moving it up and down and left and right and stretching it and compressing it and that sort of stuff. Make sure that you know your table of values for your square root graph. Okay, let's take a look at another function. So now let's take a look at this function. This is called absolute value. And the absolute value bars, those are the bars on either side, just means that no matter what I put into the function, a positive number will come out of the function. So this is x and this is f of x. Okay, so it does not matter what you put in, automatically it will be switched to a positive coming out. That's what absolute value does. So let's show you. So -3, -2, -1, 0, 1, 2, 3. Let's do a few more numbers this time, just to really show you what the graph looks like. Okay, so if I put in a -3 into my absolute value bars, then my output is going to be a +3. So it's the exact same number. No calculations are done. It's just that it will always be positive. So -2 goes in, +2 comes out. -1 goes in, +1 goes out. 0, 1, 2, and 3. So it's the exact same number, just always positive. And when you go to graph this, so -3, +3, -2, +2, -1, +1, 0, 0, 1, 1, 2, 2, and 3, 3. It looks very similar to the parabola, but it's actually not a parabola. It is a V shape, okay? It has that hard, we call it a cusp, actually, where these two lines come together. It comes at that angle. It is not a smooth curve. It is a point, and so therefore we call it's the absolute value graph. So that's how it's different than the parabola. There's no round here. It's not rounded edges. It is an absolute V that happens. And that's maybe some way that you can remember it. Absolute value creates the V, V for value. So whatever goes in comes out as a positive. All right, again, we need to remember our base graph. And let's keep going. Okay, the next graph that I'd like to take a look at is our cubic. All right, so a cubic means that whatever number I'm going to put in, we're going to cube it. So we're going to times it by itself 3 times. So let's go -2, -1, 0, 1, 2 for just 5 points. Okay, -2 cubed is -2 times -2 times -2, which is -8. -1 cubed is -1 times -1 times -1, which is -1. 0 cubed is just 0. 1 cubed is 1. And 2 cubed, 2 times 2 times 2 is a +8. Okay, so let's go ahead and plot these points. So -2, -8, -1, -1, 0, 0, 1, 1, 2, and 8. All right, and what we actually get is like an S or a snake that kind of slides up our y-axis and crosses over at 0, 0. So that's what we get when we get a cubic, okay? It's almost kind of like a linear in that it starts, down and then goes up, but we get this nice curve at the middle part of it. So I always like to call it the snake, like it kind of slides its way up the graph. All right, so what we need to remember there is that when you put an input in, it is cubed, so we're multiplying it by itself 3 times. All right, 2 more to look at, just 2 more to look at. Let's start with the rational graph. So the rational graph is 1 over x. So this is x and this is f of x. Okay, so let's use -2, -1, and -0.5. And the reason why I want to do that is because we can't use 0. I can't put 0 in for x because notice if I put 0 in for x, I would get 1 over 0, and that's undefined. And then let's go on the other side of that. Let's do a positive 0.5, a 1, and a 2. Okay, so if I put a -2 in for x, I'm going to get 1 divided by -2, which is -0.5. If I put a -1 in for x, I'm going to get 1 over -1, which is -1. And if I put in -0.5 for x, I get 1 divided by -0.5, which is going to give me -2. If I put in a 0.5, I'm going to get 1 divided by 0.5, which is 2. 1 divided by 1, which is 1. And 1 divided by 2, which is 0.5. Okay, so let's plot these points. So -2, -0.5, -1. Oops, I'm way off on that. I apologize. -2, -0.5, it's underneath. -1 and -1. And -0.5 and 2. All right, and then 0.5 and 2, 1 and 1, and 2 and 0.5. Okay, and what we actually get, it's pretty neat. It's this graph that runs along the x-axis and down. And like this. And it never actually crosses our x-axis or our y-axis. So you might remember a few lessons ago, I asked you to figure out what asymptotes are. So asymptotes are exactly that. They're lines, either vertical or horizontal lines, that the graph gets really, really close to, but never actually crosses. So here we have asymptotes at x equals 0. So x equals 0 is our y-axis. And at y equals 0, so our x-axis. All right, those are asymptotes. So this is what the graph looks like. It's a little bit more difficult, I want to say, than the other ones we've done so far. Obviously, there's asymptotes in there, and we couldn't use zeros, and we had to put in a fraction or a decimal into our inputs, and then fractions as outputs, and therefore, but this is what it looks like. Okay, last one, I want to talk about the function 2 to the power x. So if x is the actual exponent, so let's do x, f of x, -2, -1, 0, 1, 2. Okay, so if you can remember about negative exponents from grade 10, if you have a negative exponent in the numerator, you can make it positive by putting it in the denominator. Or in this case, you can just use your calculator. So if I put in 2 to the -2 into my calculator, I would get 1/4 or 0.25. And if I put in a -1, I would get 1/2 or 0.5. If I put in a 0, I get 1. If I put in a 1, I get 2. And if I put in 2, I get 4. And if you kind of look at what's going on with our table, you can see that it's doubling every single time. So this doubles. And that comes from that base of 2. The base of 2 is what causes it to double every time. So -2 and 0.25, that's about here. And -1 and 0.5. And 0 and 1. And 1 and 2. And 2 and 4. There we go. And it looks like this. So this is our exponential graph. Again, it also has an asymptote. This time it's our x-axis. So y would be equal to 0 would be our asymptote of the x-axis. Okay, so we have a whole chapter actually dedicated towards the exponential function, 2 to the x, or 3 to the x, or 4 to the x. Anyways, so we'll take probably a closer look at that one when we do that chapter of exponentials. But you should just know for the base graph of 2 to the x right now, this is what it looks like. Okay, so that should bring me to the end of the base graphs. It does. Perfect. So then our next step is going to be our transformation. So we're going to start looking at how do I transform these graphs? How do I move them up and down, left and right, and do some vertical and horizontal stretches and compressions. Okay, so remember, if you have any questions, ask me. There's no homework on this. Just memorize these base graphs. You need to know these base graphs. So that's the homework. Memorize the graphs.